So this is the second video about solving quadratic equations. In the first video, I did problems 1, 3, 5, and 7, showed you a few different methods. And this one, we're going to go through 2, 4, 6, and 8 and see if we can't use some of those same methods as we're solving these problems. So let me go ahead and scroll on over to number 2 and zoom on in. The big thing with problem number 2 is this is not written in standard form. And so since it's not written in standard form, I want to write it in standard form. So this is going to be w squared minus 10w minus 24 equals 0. Now that it's in standard form, I want to see if I can factor it. Factoring in this case is going to require multiplying to negative 24 and adding up to negative 10. One thing you can do if you are kind of keeping track of what you're working on here, this is my little notation for what I'm multiplying to and what I'm adding to. So I want to fill in these two parentheses to multiply to negative 24 and use those same two numbers to add up to negative 10. One thing with this problem is there's an initial thought that maybe you could use 4 and 6, but unfortunately you can't in this case because you would need both a negative 4 and a negative 6 to make negative 10. But if you had negative 4 and negative 6 when you multiply, that becomes a positive 24. So just because that set doesn't work, all right, we're going to try something else. In fact, I'm going to try negative 12 and positive 2. I know that multiplies correctly. And negative 12 plus 2 absolutely makes negative 10. So those are actually the numbers I want to use in my two factors. So we're going to have w minus 12 and w plus 2. Once it's in factored form, I'm going to take each factor and I'm going to set it equal to 0. I'm going to solve these. All right, so w is equal to positive 12 and w is equal to negative 2. So there's my two answers. I was able to factor that and solve it. You could, once it's in quadratic, nope, say it again right. Once it's in standard form, you could have used the quadratic formula as well. You would have been able to simplify all the way down to 12 and positive 12, negative 2 as your final answers. Okay. Number 4 is written in standard form. Again, we have this 2 in front, so we've got to be careful when we're doing our factoring. So I'm going to go ahead and split this. So 2a, that is a horrible looking a. Let's try that again. A, there we go, another a. And let's see if I can make this be, let's go negative, positive. Now, part of guess and check is I have now made a guess, but I want to check it. And the nice part about using my iPad here and a stylus is I can do a quick check and then erase it. So 2a squared plus 4a minus 5a minus 10. Combine the middle terms and I do get back to what I started with. All right. The reason I do that check is because sometimes there are factors that look like they should work, but when you actually check them, they don't. So just be careful. And again, I make mistakes. It happens. So I want to check my work. Once I've got it in factored form and I've checked to make sure the factors are correct, I'm going to go ahead and set each factor equal to 0. And once it's set equal to 0, I'm going to solve the two little equations here. So 2a is equal to 5, which means a is equal to 5 over 2. We'll leave it as a fraction, please, and thank you. And then separately, we've got a is equal to negative 2. And there are my two answers for problem number 4. Okay, again, factoring. AC method is the other way, or if you want to avoid factoring completely, you absolutely could use the quadratic formula on that. I'm going to scroll on down to number 6 here. Oh, excuse me. Number 6, we have a single little x squared here surrounded by some stuff. So I'm going to make that other stuff move. All right, I want to isolate the x squared. So we've got 4x squared is equal to positive 28. I'm going to divide both sides. So x squared is equal to 7. At this point, I am going to take the square root of both sides. And on the left side, I just have x. And I'm going to put the plus or minus on the right side, along with a root 7. Now in this case, it's a positive number under the root, so this is a real answer. Don't have to worry about using I or imaginary numbers. And 7 is a really nice prime number that is not going to be simplified any further. So problem number 6, you're officially done right there. The only reason you could possibly change this answer is if you had directions that told you to find decimals, or this was some kind of real world problem. Maybe that would end up being an issue. But for this one, it just says to solve. I have solved. Problem number 6 is done. All right, last problem in our set here, problem number 8, 3x squared minus 4x minus 7 is equal to 0. This problem, I believe, is factorable. Let me do a quick check here and see what we get. So let's go 3x, x, 7, 1, minus, plus. All right, let me do a quick check. So 3x squared. Let's see, plus 3x minus 7x minus 7. Yep, it's factorable. Now, having said that it's factorable, I'm actually not going to use factored form. One of the things I said a couple of times in both the last video and in this one is if it's in standard form, whether you can factor it or not, you can still use quadratic formula. And so I'm actually going to use quadratic formula in this one to show you how it will look. In case you run across this, or in case you realize at some point you're doing a problem that could have been factored. So quadratic formula doesn't change. All right. Well, actually, I take it back. It does change if I do it wrong, but let me make sure. So now opposite of b plus or minus square root b squared minus 4ac all over 2a. All right, I got it written down right. I do take a moment and off to the side, give myself a little list. A is equal to 3, b is equal to -4, and c is equal to -7. This is mostly just so I can use these quick references. I have been known on occasion to drop a negative sign, so I just want to be careful that I'm not losing things as I do the problem. So x is equal to the opposite of b. Well, the opposite of -4 would be +4, plus or minus. All right, we're going to do b squared minus 4. A is 3, C is -7, all over 2 times A. All right. So in the same way that I did simplification in the past, I'm going to take everything under this square root and I'm going to throw it into my handy dandy calculator because that's not going to happen in my head. So let's see. -4 squared minus 4 times 3 times -7 is 100. 2 times 3 is 6. Okay. So now this root, the square root of 100, well, 100 is a perfect square. So the square root of 100 is just the number 10. All right, so this big, quadratic formula has turned into this little, right, equation down here. And I'm going to further separate this, all right? This plus or minus here means I actually have 2 expressions. So I'm going to separate this up into 4 plus 10 over 2. And separately, I'm going to do 4 minus 10 over 2. Okay. So 4 plus 10 would be 14. 14 divided by 2 is 7. Let's see. Whoa, why am I using 2's in the denominator? Wait a minute. Hold it. Back up. Helps if I actually write down what's in the problem, doesn't it? And for anybody who's yelling at the screen, keep yelling, all right? This is the part of making mistakes that happens. Okay, let me double check here. So 4 plus 10 over 6 and 4 minus 10 over 6. I am sorry about that. All right, let's try this again. All right, 4 plus 10, yeah, that's still 14. But 14 over 6, definitely not 2. Or 7, or whatever I said the first time. So let's see, 14 over 6 would be 7 over 3 when I reduce it. Let me double check, because apparently now I need to make sure. I'm making some goofy mistakes. All right, 7 over 3 is right. And then separately, we've got 4 minus 10, -6. -6 divided by 6 would be -1. I feel like I should be putting that in a calculator at this point because I want to double check to make sure I'm doing something wrong. Oh, we all make mistakes. It happens, right? All right, so we've got two answers here. X is equal to 7 over 3 and x is equal to -1. Yes, both of those are valid answers. And yes, you could have gotten both of those by doing factoring. Maybe I should have factored this problem. Anyway, all right, hopefully this has been okay in terms of giving you some help with showing you that, yes, you can still use quadratic formula in some problem that could have been factored. Just don't do what I did and make a goofy error. Or if you do, you know what? We make them. It happens. I hope this has helped. Thanks so much for watching.